Hey you guys, welcome to my project. I've designed and prototyped this thing. What is it? It's a dual fan controller for my truck. It's a 3rd gen Toyota 4Runner. It's going to control staged dual spow fans over an aluminum radiator. I'll start a forum thread over at the T4R forum. There'll be a link below if you want to follow along with the project. Why am I doing this? Truck stays cool, but heating can get marginal on these, and I'm thinking about adding a turbo, which can be tougher to heat, and plus I can't help it. Some people make an argument about, well, electric fans aren't any better than mechanical fans. But the main idea with this is mechanical fans, they're always going and they have a clutch, but there's a lot of cases that I don't need or want the fans on. So I expect, number one, with a much more efficient cooling system, that the duty cycle of when it's needed is going to go down, as well as some instances that I don't want the load from the fans going. I put an aluminum Champion radiator and dual spow fans into my 61 Pontiac. That has 527 horse, and those can be really tough to stay cool. But that setup I put in there keeps it just super flat at prescribed temperatures. I've had that sitting in traffic on days that have been well over 100 degrees, and it stays cool real nicely, and I tend to flog on that car pretty hard. That car is controlled via Mega Squirt on the fans, and it's staged and it works real well. But I don't have Mega Squirt on my 4Runner. There's some off-the-shelf controllers that I could get, but they're missing some features that I wanted to add, as well as integrate a coolant sensor that's already in the truck, which is part of the ECU. And the off-the-shelf controllers, they usually have this probe that goes into the radiator fins, and they're kind of a cheesy setup. So I set this up based on Arduino. This is, for prototyping purposes, this is a Arduino Uno, and it's just kind of easy to plug in the prototype circuitry to make sure that it works. It'll ultimately be set up on the Arduino Nano. It's a super tiny thing. It's an open source deal that you can just kind of code your own stuff, load it onto the chip, wire your sensors in, and it's good to go. This is just a 16:2 LCD readout. You can't see it right now because I need to adjust the ISO on the camera. But what the features that I wanted to do is I wanted to have staged temperatures that the fan 1, fan 2 comes on. I want that to be adjustable. I wanted the hysteresis to be adjustable. That's basically the temperature that the fan comes on, and you don't want it to just go back and forth at that temperature. You want to have it so that it won't turn off until after it's dropped a few degrees. I want an AC shut off, and I want that from the condenser split temperatures. I'd rather not just have it kind of come in from the AC switch that turns the fans off, because there's a lot of instances that you turn the AC on and you're not going to need airflow from your fan on the condenser until you actually need it. I want a wide open throttle shut off, take a load off the motor, especially these 4Runners. They don't have a ton of power, so I'd like all I can get when I want it. I want to shut off while the starter's cranking, need all the power we can get there so we're not loaded. A shut off at highway speeds, so even if it is up to temp and you hit highway speeds, tell it, hey, you don't need to keep going, and then have some safety overrides in there.
I want a hot dog, I want a milkshake, I want potato chips.
You'll get nothing like it.
So the setup here, this is what's called a breadboard prototype. It's just to sort of test the logic, test the circuit. And this is where I am now. With that, I'll kind of show you the logic, how things work. First, one of the sensors, this is a thermistor, and that's what I'm using to pull in the temperature from ambient as well as from the AC condenser. It's the same thing that the OEMs use, and it's spec'd so that for weather and everything like that, for ambient, it'll get placed in front of the radiator, and just put it in a spot that it won't ice over or anything like that. So here, let me stick it in my butt for a moment so you can see it in action. All right. All right, so you can kind of see how it reacted there. You can see, let me give you a little bit brighter here. Okay, so with that, I'll show you some of the logic. Right now, the way that it's programmed in, and I have a potentiometer on the breadboard, which is to say, for testing purposes, I can manually adjust the coolant temps here. So, you know, we'll go down to 165 degrees. And I've hard-coded in the sensors that are going to get pulled in right now. Right now it's set throttle 30%, just like you're on the highway. RPM's 2,500, voltage 14.2. 100 kilometers an hour, which is 62 miles an hour. AC is programmed off, but take a look sort of what happens here. Coolant climbs up. It's set right now at 195 degrees. Fan 1 will come on. All right, so the reason that the fan didn't come on is because I had it set at highway speed, 62 miles an hour. So I just hard-coded in the speed at 12 miles an hour, and you can see now that the fans are off. It's 165 degrees of coolant temp. We raise the temp up, and we hit it at 195 degrees. Should come on. Boom. Comes on. You can see on the breadboard I have an LED. You can see the readout. Fan 1's showing that it's on. I have the hysteresis set, I think, at 4 degrees. So fan comes on, starts cooling it down. I think it's gonna be 191. It'll probably pop off. Yeah, fan comes off and it heats back up again. 195 degrees, fan 1 comes on. 200 degrees, fan 2 comes on. It's going to have hysteresis again, so 196 degrees, fan 2 comes off. Let's heat it up again. I have a top end, sort of a panic zone at whatever, I don't know, panic. It's probably not ever going to hit it, but at 205 degrees, it's basically saying, hey, I'm working as hard as I can, and I'm not going to shut off some of your overrides. So I'll show you some of the other overrides that I put in. Okay, first override that I put in, just like I had before, is at highway speed. It's at 62 miles an hour again. That's adjustable. I put it in at, I think, 50 miles an hour. So you can see it says highway. With that, you know, at 182 degrees, it wouldn't turn on the fan anyway. But at 195 degrees, it still doesn't come on. 200 does not come on. But then we hit that sort of panic zone, and it says, hey, what's up? We're going to set on those dual fans. Okay, so here I put in a condenser split temperature at 25 degrees. So you can see it actually shows the split temperature, and it shows that the AC is on. So even at 165, that fan 1 is on. When the equipment gets installed in the truck, then fan 1 should obviously be the one behind the condenser. But in any event, fan 1's already on. Come up. We hit 200 degrees, fan 2 comes on. 4 degrees under 200, fan 2 goes off. And again, we have kind of that 205 degree, I really want the fans on situation. So I'll show you the next condition. Okay, so I just hard-coded that the throttle is at 90%. I think on my ECU, when I put the pedal all the way down, the ECU reads it like at 85% or something, so it's not a true 100%. So when I program in what watt is, I got to take that into consideration what the ECU actually thinks. But wide open throttle, fans are off. Even when we hit the first threshold, 195 degrees, even when we hit the second threshold, 200 degrees, but the rules change at 205 degrees. Start rolling the fans on. Okay, so I put in a voltage override for a couple reasons. Number one is that if you're having charging problems, you need to preserve as much battery as you can to get home. And the second reason is, so first you'll see as the temperature climbs, it's not going to turn on at 195, it's not going to turn on at 200, rules change at 205 or whatever else you program it in at. And then it'll run as much fans as it can. But the second reason for the voltage override is during starting conditions. I think I have it set to 12 volts is the trigger for this. And when you're cranking your starter, your voltage dives below 12 volts while the starter's cranking. So this shuts the fan off and gives all the juice to the motor. Okay, so here I have the RPM set to 0. So just the keys in the car. And motor is not running. And no fans. But if the motors needs the fan or wants the fan, it'll turn it on. So if it's 195 degrees or whatever, it'll keep cooling down for you. Same logic, you hit 200, two fans, rules change there. So okay, here I just set the RPM to 200. So this is when it's actually cranking, and I think I have a threshold set in there at like 400 RPM or something that's going to be less than your idle RPM, but more than 0. So as you're cranking, it's got an override. Just give all the, and this is redundant with that voltage deal because volts are going to dip too, but it does have the override for over 205 degrees. Which you probably shouldn't be starting your car over 205 degrees anyway, or however you want to set that. Maybe you want it hotter than that for sort of your top end stuff. All right, so here's sort of the schematic that I have. And this is an explanation of where I'm going to pull in some of this data. I found this guy, he's an Arduino guy, he's in Australia, and he built this little thing that plugs into the OBD2, and it has the right protocols for my truck. It has 4 wires going into it. There's basically 2 wires here. That's the CAN bus, goes into the transmit and receive pins. There's a ground wire, and it also has 5 volts coming out of that. However, I'm not going to use the 5 volts coming out of this to power the Arduino. I'm actually going to have a 5 volt regulator here because I want it to key off when I turn the car off. OBD2, would continue to feed the 5 volts, and there's more than what is acceptable for parasitic draw here. The Arduino spec, you can actually use a car battery at, they say you can use up to 20 volts, but this will clean up the voltage and take away any noise from the car. This is an LCD readout, and this purple dash line is basically the casing that you can put all the components in, and if it's designed right, you know, a little bit bigger than this. These are very small transistors, which are going to drive the relay pins, fan 1, fan 2. The thermistors, those are really small wires that are going to come in here. They go through a couple resistors to the analog pins. And there's that. I mean, once it's built, there's just 4 wires coming in from the OBD2 adapter, and there's 4 wires coming in, 2 wires from the thermistors, and 2 wires coming out to drive the low current pins. They're just going to be Bosch Automotive relays that are super reliable and good to drive these fans.